Hello, Professor Batsman. Here is my implementation for part 1 in the number 3 scalable and efficient rigid body simulation. So what I did is to propose a new scene with a total of 60 objects. Um, those are arranged in groups of 5. In total, I have 12 of those clusters of objects that are quite close together. And what I did is to change this part of the code that exhaustively checked every two objects in the scene to detect and to handle collisions. So this is the original behavior. I am printing out the number of collisions processed at every delta time. These are a total of 1,770, and it's kept constant, even though some objects are very unlikely to collide, like this, for example. This is all the time compared to each of those, each of the other uh, boxes in the simulation. So now I will jump to my approach, which is in this branch locally, of course. So what I'm proposing is not to do with the object collision detection handling exhaustively, of course, but to only check for a list of those that are very likely to collide. So what I implemented is this function that brought a vector of pairs of objects. These are their indices of every box in the simulation that are very likely to collide. So what I do in the simulation is to input a number of the clusters of objects that I expect to have in my simulation. They should be approach specific to certain environments where I have clusters of them of objects. Um, so what I do is to program a Cummins algorithm. I initialize the number of centroids according to the clusters of objects that I expect to have. In this case, I should have 12 of them in my scene. I've run the Cummins algorithm, and at the end, what I have is, of course, the centroids of each of the groups and the IDs of each of the objects that are closer to each of the centroids of each cluster. With those groups of IDs, I would go and create bounding pods over each of the objects in the simulation and only compare and identify the overlapping bounding boxes that are in the same cluster, ignoring those that are from different clusters. So yeah, this is where I build the list of objects that are very likely to collide, and I ignore those that are not in the same cluster, so they should be quite far away. I will run the simulation again, and I'm printing every time the number of expected possible collisions that we have in the simulation, and this number should be much smaller than the one that we had before. So let's see. Again, the same simulation, we should have the exact same behavior. So at the beginning we have a very good number here. This is quite small, only 20 possible collisions when this first group of objects collided with the ground and then the other ones, the number of collisions expected grew for a while, and as the objects spread out in the ground, less and less objects are likely to collide. So at a certain moment in time, I'm getting only one or two possible collisions instead of the 1,770 that we had before. So yeah, thank you very much.